The idea of a paradox is ancient, like literally ancient. And it's not just mathematical. A few of you, as I went around, you had maths involved in your statement, but one of the reasons why I like all of these is because paradoxes are bigger than maths. I'll give you an example. One of the most famous paradoxes is called the liar paradox. The liar paradox? Some of you might have heard it before, okay? Very simple statement, one sentence. This sentence is a lie. This sentence is a lie. Think about it. It's very short. This sentence is a lie. Let's just consider what happens. What happens if it's right? Well, if it's right, then the statement's not a lie. It's true. But wait, that doesn't work because it says that it's a lie. So my brain just okay. So that's not mathematical at all. In a similar kind of vein, can you imagine what would happen if Pinocchio said to you, "My nose is about to grow"? So for those of you who aren't aware, right? So Pinocchio's nose should grow if he lies, right? Well, if the statement is a lie, his nose will grow. But wait, he just said, "My nose is going to grow," which means it's true. And again, it's the same idea. It's just a variation on the liar paradox. Okay? So I really like all of these. Something that doesn't work. A contradictory statement, I might add to that, and you might be able to tell from the two examples I just gave you. Often we end up with paradoxes when statements or ideas are self-referential. That's a really important idea. Self-referential ideas. Things that refer to themselves are often paradoxical. Okay? A statement that breaks the norm. So things are generally accepted to be true, but then something comes along and it's true as well, but it disagrees with other things, right? Or lastly here, a falsification. Sure. Which is also considered legitimate. I really like this. I'm glad we got to include it at the end because this is going to get at, there are two big classes of paradoxes. Okay, and I'd like you all to write this down. And you can have this is kind of underneath this idea. I'm just going to try and reword it a little bit. Okay? The two main kinds of paradoxes are things that are true, right, but they seem false. Right? You say it to someone and they're like, "No." Really? No. But yeah, really, okay? Alternatively, the other kind, any guesses what the other kind might be?
False, but seems true.
Good, the other way around, okay? Things that, if you apply your logic and your deduction, all that kind of thing, you're like, this is true, this is true, this is true. And what you end up with, even though it seems true, is actually a lie. So we're going to have a look at some kinds of these. We're going to start off by having a look at this kind of category of ideas, right? These are often called, this particular kind of paradox is often called a fallacy. What I'm going to do is I'm going to try and come up with things that seem to hold together, that seem valid, that use the rules you're familiar with and you agree with, but I'm going to end with something which is clearly wrong, okay? So here's our classic one. We'll start with the algebraic one, which is, we're going to start off with two numbers, A and B, but they're actually the same number, so long as they're not zero. Okay. Two numbers, not zero. You happy so far? So, this is not a complicated idea. You can have numbers that are the same all the time, but what are we going to do with them, right? And by the way, when you spot what's wrong, because within this room, particularly thinking about what we've been doing over the past few months, I hope I'll be able to do this slowly enough and clearly enough that you should see it immediately. I hope, if I've done my job, okay? But I don't want you to shout it out. I just want you to let me run my course, okay? Because it's a very famous result. Here's what I'm going to do after this. I'm going to multiply both sides by A, which gives me this. Okay. I'm then going to, I'm pretty sure everyone has seen some variation of this, okay? I'm going to subtract b squared from both sides. So I'm going to get this. Okay. Right. Now at this point, I've got a whole bunch of terms I can factorize here. Right? So I'm going to factorize over here, and I'm going to factorize over here. Okay. I have some common factors, so I'll get rid of those. What's common on both sides? I'll get rid of that. Okay. So far, pretty ordinary. But I know that A is equal to B. That's how I started off, right? So it looks to me like 2 equals 1. Gotcha. Okay, now, say nothing, okay? Raise your hand if you can see where the problem is. Okay, alright, good. I'm very glad I didn't get you to shout out because that means that quite a few of you still need to think it through, okay? There are not that many lines here. The error must be hiding in there somewhere. You know it must be because this can't be true, right? So where is it? Right, so there you go. Fallacy number 1.